This presentation is a training aid for the Spill Prevention, Control, and Countermeasures Plan, also known as the SPCC Plan. It was developed for Joint Base Charleston Weapons Station's open water facilities by the 628th Civil Engineering Squadron Environmental Element. A hard copy of the SPCC Plan can be obtained at the Civil Engineering Squadron Environmental Element in Building 721 at Joint Base Charleston Air. Instructions to obtain an electronic copy will be provided later in this presentation. Your point of contact for this training, as well as any questions concerning the SPCC plan or requirements, is the Storage Tank Program Manager at the Environmental Flight, Ms. Mattia Wright. Her phone number is 843-963-4518, or you can email her at mattia.wright@us.af.mil. The topics to be discussed during this presentation include what is in the SPCC plan. Also discussed will be periodic inspections of oil storage tanks, as well as responding to spills. So why worry about oil spills? Well, clearly in the past, we are familiar with the Exxon Valdez oil spill or the BP oil spill in the Gulf of Mexico. And obviously, these events had huge detrimental effects on the environment. But these products are used every day in our everyday life by everybody. It is the environmental engineer's job to find the controls and mechanisms to prevent the release of these chemicals while not interfering with their availability for everyday use, including the production of food and their uses in the actual food we eat. It is inherently obvious that we want to keep chemical hazards along with their wastes separated from the areas where we live. Even the chemicals used to produce the food that we eat need to be kept separate from the food itself. When spills of chemicals or oil occur, there is a possibility of people being exposed to these materials by various methods. If any of these chemicals evaporate, for instance, they could become part of the air or smog and be inhaled. It is also possible that the contaminants can work their way into drinking water sources, and people can be exposed by drinking polluted water. Also, if some surface waters are contaminated and that water is used for irrigation, there could be direct contact and exposure to food, and eventually exposure to people through eating that contaminated food. This is what we are trying to prevent: the exposure of people to chemicals that may be detrimental to their health. Let's discuss from where the authority of the SPCC plan was originally derived. In 1972, the Congress passed the Clean Water Act. Once passed, the Environmental Protection Agency, the EPA, was required to develop regulations to assist industries with complying with the new act. Some of the regulations developed required industries and certain facilities to develop plans to prevent the occurrence of spills and other hazards, namely SPCC plans. The Air Force, in turn, has developed instructions requiring installations to have individual SPCC plans that are at least consistent from installation to installation. Here is the cover page of the most recent finalized version of the SPCC plan for Joint Base Charleston Weapons Station open water spill response. You can request an electronic copy of the latest version of the SPCC plan by contacting Mr. Earl Folger or Ms. Mattia Wright at the environmental element at the respective email addresses shown here. A hard copy can be made available for review at the environmental element in Building 721 at Joint Base Charleston Air. So what is in the SPCC plan? First, there are requirements for building and installing tanks. As these efforts fall under the purview of the Civil Engineering Squadron environmental element, they will not be part of this presentation. Second, there are requirements for after a tank is installed. These may include training and/or inspection requirements and procedures when spills occur. Let's look at some of the requirements after a tank is installed. First, there are training requirements. There is both initial and refresher training required by all personnel involved with oil transfers or handling. This is what you are participating in right now. There are also requirements for inspections to ensure that tanks are not leaking, as well as requirements for when a spill occurs and proper notification procedures. For now, we will discuss general aspects of tanks and berms, as well as some procedures and periodic inspections, and deal with spills and notification procedures later in this presentation. This is a partial map of the weapons station taken from Appendix 2 of the SPCC plan. Due to the size of the weapons station, it takes many of these maps to cover the entire facility. The purpose of these maps is to show the POL facilities at the base. POLs, of course, are petroleum, oils, and lubricants. We are just using this one map as an example. You can acquire the map for your specific facility through the previous methods discussed in this presentation, so you have the pertinent information for any tanks under your purview. These maps not only provide the location of POL facilities, they also provide information such as stormwater ditch and stormwater pipe locations, as well as the stormwater inlet locations, which is vital information in determining where a material may travel should a spill occur. The light blue line with the black arrowhead represents the predicted spill flow path. In this case, a spill from the drum storage area at Building 907 at Pier Charlie would flow towards the Cooper River. Make sure a tank is not leaking when you fill it up. Duh! Someone has a painful grasp of the obvious. But this is why SPCC plans are written and standard operating procedures are developed. In Appendix 6 of the SPCC plan, there is a checklist to be used when refueling tanks. At the top of the form, there are some conditions and safety items you should observe when refueling a tank. The middle of the form provides several steps in preventing spillage while refueling a tank. For example, you should verify that the receiving tank has the capacity to receive the quantity you are trying to transfer. By checking gauges before transfer and during the transfer, you can ensure that spillage will not occur. As you approach the maximum quantity of the transfer, you should back off on the pumping speed to ensure no spillage occurs. You should do a quick walk around the tank and check for damage of any kind. Be sure to check the berm and any other interstitial space for fuel. If there is already fuel in either of these areas, there is obviously an issue with the tank, and the refueling should not occur. Be sure that the truck has containment supplies on board, like absorbent materials or a drip bucket, etc., or that they are available at the facility itself. Be sure everyone involved in the transfer knows where the emergency cutoff switches are. You should visually verify that all hose connections are not damaged and that the hoses are in good shape. You should remain with the fuel delivery truck for the entire transfer and hose breakdown. It is during the hose breakdown that most commonly spills will occur. You should verify the amount transferred from the receiving tank and make sure to lock all fill caps in place on both ends of the transfer. Appendix 6 also provides a vehicle refueling procedure. This form provides both safety and spill prevention and control measures which should be followed during any vehicle refueling procedure. Sources of flames, sparks, or ignition are not permitted in the fuel storage tank area at any time. This should be noted that it also includes e-cigarettes. You should be attentive during the refueling process. Do not sit in the vehicle waiting for the refueling to finish. And do not be distracted by a cell phone or any other electronic device. You should touch the vehicle prior to inserting the fill nozzle and prior to removing the fill nozzle. This lowers the risk of a fire starting from a static electricity discharge. No fuel transfers shall be made while motor vehicle engines are running. To help prevent spills, you should follow normal operating procedures for starting up the pump and opening valves on the tank. Keep the nozzle pointed upward until placing it into the vehicle's tank fill tube. When you are finished refueling, replace the nozzle into its cradle, shut off the system, lock up, and complete any documentation you need to. Remember, you should never try to top off the gas tank by continuing to squeeze the nozzle after it automatically clicks off the first time. This behavior is the leading cause of spillage from overfilling vehicle gas tanks. You should notify the facility manager if any fuel has spilled during the process. A couple of drops may be reasonably acceptable, and sometimes it's impossible to avoid. However, anything more than a few drops must be reported to the facility manager. Static electricity is a charge that is at rest or not moving. However, if a conductive path is provided for the static electricity, a static discharge or spark can occur. For example, a person walking across a carpeted floor, the conductive path, reaches for the doorknob and zap! They receive a static shock. This happens because static electricity is generated when the person walked across the carpet. The same scenario can also occur when you are pumping gas, whereby the spark could ignite gasoline vapors and may cause a fire or an explosion at the pump. Due to the importance when you are refueling vehicles at Joint Base Charleston Air or your own personal vehicles, we want to reinforce these important safety tips outlined below. Always turn your vehicle engine off when refueling. Do not re-enter the vehicle while refueling because this can recharge your body with static electricity. If you must re-enter the vehicle, discharge the static electricity buildup by touching the outside metal portion of the vehicle away from the fuel tank. Never smoke in the refueling area. Keep cell phones and other electronic devices turned off while refueling. And never allow children to pump gasoline. Some safety tips for filling portable gasoline containers include: when dispensing gasoline into a container, use only an approved portable container. Never fill gas containers while the container is placed on the inside of a vehicle, in the trunk, on the bed of a pickup truck, or on the floor of a trailer. Touch the can with the gas dispenser nozzle before removing the can lid. When filling a portable container, manually control the nozzle valve throughout the filling process. Fill the portable container slowly to decrease the chance of static electricity buildup. Fill the container no more than 95% full to allow for expansion. Place the cap tightly on the container after filling, and do not use containers that do not seal properly. When transporting gasoline in a portable container, make sure it is secured against tipping and sliding. Never leave a gasoline container in direct sunlight or in the trunk of a car. Should a fire occur during refueling, you should leave the nozzle in the vehicle and back away from the vehicle. Use the emergency shutoff button to shut off the pump and notify the station attendant. Now let's discuss monthly tank inspections. The AFI requires monthly tank inspections. Primarily, these inspections are performed by the owner or operator of the tank. That means if you have a tank at your facility, you are responsible for its monthly inspection. Tanks attached to generators are primarily inspected by PowerPro. There are also annual tank inspection requirements, but those more in-depth inspections are performed by the CE environmental element. In Appendix 8 of the SPCC plan, you will find an example of a monthly tank inspection checklist, as seen here. This form is for a specific tank found in the STARS database. You can print out the checklist for the particular tank you are inspecting. Go into the field to perform your inspections. Answer the applicable questions on the checklist, and upon return to the office, you can upload it to the electronic version of the STARS database. We will discuss that option later in this presentation. Your first concern when you go out to inspect the tank is the inspection of the tank itself. There are various kinds of tanks at Joint Base Charleston Weapons, which we will discuss later. For instance, single-walled tanks versus double-walled tanks. For this discussion, however, we are talking about what you would naturally perceive as the tank, which would be both tanks of a double-walled tank or obviously a single-walled tank. You should carefully inspect the tank and its support structures and answer the questions that are applicable on the checklist. This picture shows examples of a double-walled tank as well as single-walled tanks. The tank on the far left is a double-walled tank. there is one tank inside the actual outside tank that you see. This outside tank performs as a form of secondary containment. The two tanks on the right are single-wall tanks, and they require a concrete berm to act as secondary containment should there be a leak. Other questions on the checklist deal with secondary containment. These questions primarily deal with berms around single-walled tanks. We will further discuss later interstitial spaces, which are found in double-walled tanks. Berms are a common secondary containment option. The interstitial space of a double-walled tank is also considered secondary containment. There are varying types of interstitial spaces and different types of tanks, which we will discuss now. This is an example of an open space interstitial space. This tank looks like a normal tank, halfway set into a box. This tank happens to be located at the hazardous waste facility at Joint Base Weapons. The box portion of the tank is the open space. The hatch allows you to look into the open space to see if there is any leakage from the tank itself, which you can see on the right-hand side of this photo. This is an example of a porous space interstitial space. This interstitial space is filled with a sand-like material or grit. The only way to check to see if there is any evidence of a fuel leak of the interior tank on an interstitial space of this type is to check the sensor readings. The sensors will be at the bottom of the interstitial space. This is an example of a sealed space interstitial space. It is basically the belly tank of a generator. These interstitial spaces are usually checked electronically or automatically using various types of sensors. Since some interstitial spaces are sealed, as are many double-walled tanks, and use sensors to detect any leaks, as is also the case for porous space interstitial spaces mentioned earlier. It is important to note that the sensors used need to be routinely checked to ensure that they are in proper operating condition. This is an example of a semi-double-walled interstitial space. The inspection checklist for the tank you are inspecting will contain questions concerning piping. The tank that you are inspecting may or may not have piping coming out of the tank. Certainly not the large piping as is pictured in this example here. Often there are small pipes or tubing coming out of the tank going to the piece of equipment the tank services. Also, there may be a hose coming from a pump to fuel a vehicle, but this is actually not part of the tank and will be discussed in the next section. You should answer all applicable questions concerning piping on your checklist. There may also be questions on your checklist concerning pumps or other equipment. The tank you are inspecting may or may not have pumps attached to it, or they might be internal to the tank itself. You should follow the questions on the checklist and add any additional notations that are necessary for hosing or other pieces of equipment that may be part of the tank you are inspecting. Answer all the necessary questions on the checklist. Lastly, you will find questions on your checklist concerning the general conditions around the tank. So take a good look around the area of the tank and be sure to look for a spill kit. Make sure to open it and be sure that there are an adequate amount of supplies inside, and that they are proper supplies for the material that is inside the tank you are inspecting. You should inspect all other ancillary equipment like fire extinguishers, as well as any gates or doors that are in the access ways to the tank itself. There is also an electronic version of this checklist that is available online through the internet. If you are interested in using the electronic version of this checklist, please contact the Tank Program Manager at the Environmental Element, Mr. Earl Folger. He will need to grant you access and provide the necessary training for you to properly input information into the database. The Storage Tank Accounting and Reporting, or STAR module of the APIMS database, is required by Air Force Instructions 32-7044 for all storage tanks. Access to this database requires a CAC-enabled computer and proper permissions be granted to each individual user. The following slides will be a discussion about various types of tanks and berms, providing different examples at Joint Base Charleston. The first of which is a vault tank, which is seen here in the closed position. In many cases, piping for fuel transfers are actually left fully charged or full of fuel when not in use. So when the time comes for maintenance on the line, then often the fuel is pumped or drained to this vault tank so it can be recovered. This is an example of an elevator tank, which can be found in Building 721 at the Air Base. You should note that the building itself is actually considered the secondary containment for this tank. Should there be any cracks in the floors around this tank, they should be noted and reported and repaired as soon as possible. These are an example of single-walled tanks at the NPTU facility. As single-walled tanks, they require secondary containment, which is the berm you see in this photograph. We will discuss berms a little later in this presentation. This is an example of a portable generator with a belly tank. Whenever this equipment is not in use, it should be stored in an area that provides secondary containment. Berms come in various shapes and sizes. They are designed to hold a certain portion of the fuel in the tanks or piping that they contain. Note the valve in the lower left corner, which is currently locked. This is the valve that is used to drain the berm of rainwater using very particular procedures which will be discussed later. We use the berm in this slide as an example of how a large area can be supported by a particular berm. The whole area on the left is the berm itself. There is what you would think was a storm drain in the middle. The valve highlighted in the middle of this slide, which can originally be seen towards the left, operates the valve that would release the rainwater from the berm after it fills up. On the right, you see the area in this particular situation where that storm water would drain to. Of course, this happens only if there is no fuel present, following particular procedures which will be discussed later. Secondary containment is even required when parking fuel transfer vehicles, as seen here. It should be noted that tankers are only required to be in a containment area when they are unattended and being stored until the next task or assignment requires the use of the tanker. If a tanker is empty, or it is in use with an attendant in the immediate area, it does not have to be in a containment zone. As is in the case of tanks, berms are generally maintained by the owner-operator of the facility that they are supporting. The exceptions to this are that PowerPro maintains most emergency generators and that the electrical shop maintains all of the electrical transformers. For tanks, the facility that pays to have the tanks installed and is hence supporting them are also required to maintain the berms. If you paid to have the tanks installed and you pay the maintenance cost on those tanks, then you are responsible for the management of the berms as well. Here is a berm at the Aerial Port Squadron, which is maintained by PowerPro. Here are a couple of discharge valves from the berm at the Hazmart drum storage facility. As you can see, the one on the right might not have been used for a while. As mentioned earlier, berms are to be maintained by the owner and operator of the facility that they support. Maintenance of the berm can include removing any wind-blown debris or leaves or trash. All berms should have non-automatic open and close valves. These valves are to remain closed and locked until which time rainwater needs to be drained. A trained person knowledgeable in detecting sheens has to visually inspect and determine if a berm can be drained to the ground. The following procedures should be used in the process of draining a berm. First, inspect the rainwater for a visible sheen. For a minimal sheen, you can use absorbent pads to remove any product. When no sheen is present, unlock and open the valve to drain the berm. After the berm is empty, close the valve and lock it. Lastly, be sure to complete the secondary containment drainage lock. It should be noted that if the sheen is excessive or there is actually a layer of product in the berm, you should contact the environmental element for assistance in investigating the possible source. A secondary containment drainage log must be kept for all berms. This drainage log can be found in Appendix 8 of the SPCC plan. Portable tanks, when not in use, should be stored in areas with secondary containment. It should be noted if the portable tank is empty, however, it does not need to be stored in a containment area. Some portable tanks actually are double-walled and have an interstitial space and therefore a self-contained secondary containment. Tanks like this do not have to be stored in containment berms. All portable tanks should be operated in accordance with their individual technical manual or manufacturer's specifications. Specific SOPs should be followed for the filling and transfers of fuel or oil to and from any portable tank. Now let's consider the storage of drums. The drums in this particular storage cabinet are kept on secondary containment containers or pallets. This is a requirement if the area storing the drums is not a burned area. Hazardous waste storage areas have their own inspection criteria and drum inspection criteria under the hazardous waste regulations. All drums are to remain closed when not being filled and inspected on a regular basis per the regulations. This is a slide showing the drum storage area at the HazMart. As you can see, some drums are stored on secondary containment pallets and some are not. In this case, that is acceptable because the whole area is burned, as we saw earlier in the slides, in particular, the one with the valve growing in the trees. The drums on the far left against the wall are empty. Also, at the time of this picture, there were still supplies that were temporarily stored inside the facility during hurricane preparations. As an emergency condition, this is okay, but normally all drum areas should be clear of excess material, and access and clean aisles ways are mandatory. Here is an oil drum storage area checklist from Appendix 8 of the SPCC plan. This should be used to inspect the drums on a regular basis, usually at least weekly. Any other form that may be used as a checklist must be approved by the environmental element before use. Electrical transformers that contain over 55 gallons of fluid are regulated units under the SPCC regulations. Here on the left, you can see a unit that is actually in use. On the right is an extra unit that is stored in the electrical shop yard. Transformers are normally sealed with a drain plug at the bottom and the fill plug at the top. Any transformer in use should not be tampered with except by properly trained electrical shop personnel. These transformers, found on Pier X-ray at the Weapons Station NPTU facility, are the only transformers at Joint Base Charleston that require secondary containment. Due to their proximity to open water, these transformers are actually contained in a burned area on the pier to provide secondary containment in case of a spill. Weapons Station electrical shop personnel are charged with doing the periodic inspections on all transformers. The checklist shown here is found in Appendix 8 of the SPCC plan and should be used for that inspection unless another form is approved by the environmental element. Anyone on base, however, who observes that there is an issue, perhaps a leak or a spill from a transformer, should report it immediately to the environmental element personnel and the electrical shop. Now let's discuss some of the instruments and equipment that will assist you in operating and maintaining any storage tank that may be in your area. All tanks are different and have different gauges and equipment attached to them, but we'd like to just give you a few examples. Here's an example of a clock gauge. As you can see, it looks like the face of a clock. The large hand measures the number of feet of fluid in the tank, while the small hand measures the number of inches. So at the time of this picture, this tank had 1 foot and 3.5 inches of fuel in it. On a double-walled tank, the space between the two tanks is called the interstice, or the interstitial space, which is synonymous with secondary containment, of course. In this picture, you will see a K gauge, which is actually installed in the interstitial space of a tank to determine whether or not there is a liquid in that interstitial space. If the gauge indicates that there is liquid in the interstitial space, then there's an excellent chance that you have a leak in your inner tank. The particular gauge in this photo is indicating that there is not presently a leak occurring in the interstitial space. If there were a leak in the interstitial space, the small red disc that you see at the bottom of the gauge would begin to float up in the lens that you would see. One word of caution. Sometimes gauges of this type will become inoperable due to corrosion or buildup of materials around the disc inside the gauge itself. The only way to check on this is to unscrew the gauge, which you should be able to do by hand, and make sure that the disc indeed is free to move and is not corroded. There have been instances where the gauge indicated that there was not material in the interstitial space, but because of this corrosion, the disc did not rise up as expected and the leak went undetected. It is vital that you are familiar with your surroundings and observant to what is going on. You should resist the urge to be complacent during routine operations because you have done them 100 times. Always be vigilant and follow required SOPs. They were developed for a reason. Now let's discuss the last topic of the presentation, responding to spills and notifying proper personnel. In accordance with the SPCC plan, the following steps are to occur concurrently in the event that a spill occurs. First, immediately notify the Joint Base Charleston Air Fire Department. If it is safe to do so, provide emergency assistance to any injured persons. Also, if it's safe to do so, stop the source of the spill or leak if possible. Further, you should restrict all ignition sources if flammable vapors are present. And if you are properly trained and authorized, you should initiate available on-site measures to minimize the spread of contamination. Otherwise, stand by until emergency response personnel arrive on scene. Provide them with all the known details of the spill when the assistance does arrive. The key here is to recognize that anyone could perform steps 1 and 6, notifying the proper personnel and providing information to responders when they arrive at the scene. If it is safe and you are properly trained to do so, you can perform steps 2, 3, 4, and 5. But it is important not to assume that someone else is going to take care of the problem after you discover it. It is important to clean up spills as soon as possible after they occur. Various types of absorbent materials can be used to limit the spread of contamination and assist in the actual cleanup. As you can see on the left here, some pads were deployed to quickly absorb materials and stop it from spreading. And on the right, an absorbent clay or other material was spread to absorb the liquid to be swept up later. As you are cleaning up the spill, remember that all materials used will need to be containerized in a drum or other proper container and prepared for proper disposal. This material may include the absorbent material spread to soak up the liquid, for instance, the kitty litter or clay material, any absorbent pads or socks that were used, and any personal protective equipment that was worn during the cleanup. One should keep in mind that very often this waste is disposed of at a cost per pound. You certainly should use enough material to get the job done, but keep in mind any excessive material contaminated will increase the cost of disposal. However, it is more important to get the job done. Arrangements will need to be made to have any contaminated materials properly disposed of. Depending on what was spilled and the methods and quantities of materials used during the cleanup, disposal methods can vary. Now let's discuss how to dispose of materials properly. There are varying methods of disposal depending on the type of materials themselves. Recovered product. If the spill that occurred was large enough and you were actually able to recover product and it was still clean and usable, then no disposal is necessary. You should try and reuse it if possible. If the spill occurs over dirt, then we have generated contaminated soil. And all contaminated soil must be dug up and containerized. Depending on the amount of soil, this may be done in drums, or oftentimes a dumpster is brought in for large quantities. This disposal should be coordinated through the environmental element and properly credentialed disposal contractors. Contaminated equipment is used during the cleanup, such as shovels, rakes, materials, handling equipment, such as backhoes and front-end loaders. Also, there are tank parts or piping, and all this can be decontaminated and reused rather than disposed of. The materials used in that decontamination process are now contaminated and will need to be containerized with other compatible materials for disposal. The transport of all these materials should be coordinated through the environmental element, in particular, the personnel at the hazardous waste storage facility, to be sure all necessary tracking is performed and the transport and disposal occurs in compliance with all environmental regulations. Taking another look at our spill response procedures. Anyone can and should notify the fire department when discovering a spill by calling 911. It should be noted, however, that if you are using a cell phone, you must tell the 911 operator that you are calling from Joint Base Charleston Weapons. The reason for this is the cellular system may direct you to a county dispatcher in Dorchester, Berkeley, or Charleston County. But what if there's an injury at the scene? What if you can't stop the leak or restrict any ignition sources? Or you are not trained to initiate the cleanup? Then it is your job to ask for and get help and provide any known details when assistance arrives. Your first call for help should be to the fire department. Call 911. This is the simplest number to use to get all relevant parties to an emergency. The 7-digit phone numbers provided below are to specific parties that can be reached if a non-emergency exists. but further help is needed to resolve a problem. Again, call the fire department first at 911. Do not be afraid to ask for help, even if you may have mistakenly caused the spill. People don't get in trouble for asking for help. They get in trouble trying to cover things up when they should have asked for help. Remember, always ask for help. Now let's look at a few examples and see if we can determine if a spill response is necessary. Here is an example where you can see a sheen flowing directly into some sort of storm drain. Obviously, this will require a spill response. If it is safe to do so, the spill can be stopped or diverted by placing absorbent pads over the drain, or by using a granular material to dam the flow of the contaminated water. Does this require a spill response? You can see some staining on the side of the tank, where apparently a leak or spill has taken place. Looking closer at the top of the tank, it does not appear there is an active leak. The stain is not getting bigger. Should this be cleaned up? Yes. Should someone be notified? Yes. Does this require a spill response? No. The stain is not getting any bigger, and there is not an active leak. Let's take a look at this situation. A spill has occurred, but it is contained completely within a building. There is no release to the environment. It would be an obvious concern to the shop personnel and especially the shop foreman, but environmentally speaking, it has not reached the outside environment and therefore does not require a formal spill response from an outside entity. This is an example of a spill that is in progress. Does it require a spill response? Absolutely. The spill is fresh and still active, therefore it requires a spill response. Look at this picture of some stormwater with a sheen. It is apparent that this should trigger a spill response. You may also call the environmental element and have them determine if the sheen is man-made or naturally occurring. If it is naturally occurring, a response would not be necessary. It is important that you anticipate the likely path of a potential spill. This blow-up of a map available in the SPCC plan can be the resource you would use to try and determine where the likely path is going to be. The green lines indicate where stormwater ditches are. The purple lines are actual stormwater piping, with the red squares being stormwater drop inlets. The blue line with the black arrowhead tip shows the likely path of a spill from an existing POL storage facility. If you get the corresponding map in the SPCC plan that has your building or facility on it, you can then recognize where your tank is and determine the probable flow of a potential spill and where it will travel. Now that we have discussed what may or may not require a spill response, let's take the next step and discuss what needs to be done after the cleanup is complete and you need to report and document the spill. The SPCC plan covers the reporting of spills. Per the SPCC plan requirements, if there was a release to the ground or surface water and a complete cleanup was performed, then a report needs to be completed and documented. Again, to reiterate, if there was a release to the ground or surface water and a cleanup was performed, then a report needs to be completed and documented. Look at these two examples. On the left, you see a large spill with absorbent materials and obviously a large cleanup underway. This is clearly a release to the environment, and a report to either the fire department or the environmental element will be required. On the right, you see a spill that quite possibly may have made it to the storm drain and possibly extended off-site. A report will need to be made to the fire department and the environmental office. They in turn will determine whether or not a report needs to be made to any outside regulatory agency. Let's refer back to the previous situation where a spill occurred but was completely contained within a building and there was no release to the environment. This is clearly an example of when a spill report is not necessary. Here's an actual spill report. This two-page report can be found in Appendix 8 of the SPCC plan. When you fill out this report, you need to keep it for at least 3 years. It will be the responsibility of the fire chief to complete this spill report when a spill report becomes necessary. The form itself is relatively self-explanatory, but there are certain sections that we would like to stress and further discuss. The second section of the first page of the report form is entitled, "Only if directed to do so by Joint Base Charleston." Under certain spill conditions, the National Response Center, or NRC, may need to be notified. But this is a decision that will be made by the fire department chief or the environmental element chief. Do not call the NRC unless it's directed to do so by one of these two people. At the bottom of the first page is a section called Material Involved. You must document the type and quantities of material that was spilled. At the weapon station, this material will probably be gasoline or diesel fuel. You must fill in the type and your best estimate of the amount of material spilled. If the spill managed to reach a water body, such as a creek or a pond, then estimate how much actually made it to the water. Remember, even a small amount that causes a sheen on the water needs to be reported. This information will be important in the determination of whether or not an outside regulatory agency needs to be contacted. The last section to be discussed is in the middle of the second page, entitled Other Agency Notifications. Again, do not call any outside agency like the NRC or DHEC unless directed to do so by the fire chief or the environmental element chief. Now, if the determination is made that indeed an outside agency needs to be notified, it will probably be performed by someone else. However, who was contacted and when, or any other pertinent information, will need to be documented on this form, and that information will be provided to you. In closing, it is important to realize that it is everyone's responsibility to keep their eyes open for things that look wrong and report them to the proper personnel. Once again, your point of contact for this presentation or any questions about the SPCC plan and its requirements is the Storage Tank Program Manager at the Environmental Flight, Ms. Mattia Wright. Her phone number is 843-963-4518, or you can email her at mattia.wright@us.af.mil.